Hello everyone and welcome back to NotesNaka. Today is day 26 of the Lead Coding Challenge, and for today's problem we have contiguous array. So what we have to do in this, we will be given a binary array, meaning we have 0 and 1s in our arrays, and what we have to do is find out the largest contiguous sub-array which has equal number of 0 and 1. So let's check out the algorithm behind this problem on pen and paper and we will get back to the code.
In this problem, we have to find a sub-array, the largest sub-array, which has equal number of zeros and ones. So in this, we can see that this sub-array has equal number of 0 and 1. Also, this sub-array has equal number of 0 and 1. Also 0 0 0 1 1 1. So this is also a sub-array with equal number of zeros and ones, and this is also a sub-array with equal number of zeros and ones. So basically we have to find the largest one. We do not care about where it is located. So the greatest one will have 1 2 3 4 5 6. So our output will be 6. So to do this question, what we can do is, suppose the zeros are -1. So what we will do, when we encounter a 0, we will subtract. So we will have a count as equal to 0 initially. So we got 0, so we will subtract it, so we get -1. We have 1, so we will add 1 to the count, so it will again become 0. So what we can conclude is, whenever our count becomes 0, then we have equal number of zeros and ones. Let's go ahead. For this one, we can see we will subtract 1 from 0, so -1. Again we will subtract -2. Again we will add, so -1. We will add, so we will get 0, and for this we will subtract, so we will get -1. Now wherever we have the same indices like -1 1, it means that everything between that will sum up to 0, and it has equal number of zeros and ones. So for this one and this one, this entire thing will sum up to 0 and give us the conclusion that it has equal number of zeros and ones. So to solve this question, basically we have to remember all of these prefix sum. This will be our prefix sum, so we will have to remember this. So how can we remember this? The best way is to use map. So we have a map. In this, what we will do is, first of all we will initialize. If the answer is 0, then our index will be -1, which does not exist, something like that. And after that we will start from 0. From 0, what we will do, we got 0, so we will subtract 1, so we have -1. Then we look for -1 inside our map. Does the map have -1? No. So what it will do is store -1. So -1, and what is its index? The first occurrence of -1 is 0. So this is 0 1 2 3 4 5 6. So our occurrence is 0, so we will have 0 here. After that, for the next one, we will see we have our sum to be 0. So 0 is already present, -1. Whenever we get something that is already present, we will maintain a maxim which will contain our final answer. So how this maximum will be calculated? Initially it will be 0, and after that, whenever we encounter something that is already present in the map, then what we will do is index of that position minus map of that count. So what that means is, right now our I is 1, so 1 minus map, our count has become 0, our count is 0, so 1 minus this thing, so 1 minus plus 1, our answer will be 2. So our maximum will be maximum of this thing and this new thing, so our answer becomes 2 over here. That means the length of having equal number of 0 and 1, initially here we got 2. After that, what we do, we get -1 again. So -1 is already present, so again we try to calculate this. So our I is now 2, so 2 minus 0, So answer is 2. So nothing will change. We again get 2 over here. After this, what we do? We get minus 2. So when we get minus 2, does the map have minus 2? No. So it will first store minus 2. And the index of minus 2 is 3. So it will store 3 here. Now it will go here, minus 1. Is minus 1 present? Yes. So what is our index? Our index is 4 here now. So minus 1 is present at 4. So we have 4 minus 1, 0. We will minus 0. So we will have 4. So our answer becomes 4, taking maximum of this 2. After this, we again got 0. So 0 is already present. So what do? We take the index, current index, minus 0's index, which is minus 1. So plus 1, which is equal to 6. So our answer is 6, taking maximum of this 2. After that, at the last we have minus 1. Minus 1 is already present. So what we do is take the current index, which is 6, and subtract it with the index of the sum that we got, which is 0. Minus 0, which is 6. So again it will remain 6, taking maximum of this 2. So our final answer is 6, which maximum will contain, and we return maximum, which is our maximum answer. So the answer is 6 here. This is how this question is solved. So you have to use hashing, a map, and calculate the sums. If we encounter 0, we subtract minus 1. If we encounter 1, we add 1 to it.
I hope you understood the basic algorithm. So this is my code. What I did, first of all, I made a map as we discussed on pen and paper that we will be needing a map. And first initialized, if we have a 0 sum, then the index will be minus 1. So that is clear. After that, what we do is we have a count and an answer. So what count will do is we iterate through the entire array, and if num of I is equal to 1, then we add 1 to our count, and if it is 0, then we subtract 1 from our count. So that is what we did over here. After that, what we did is we checked it in our map. So if map.count of count is present, then what we do is answer is maximum of answer or I minus map of count. So the answer will have the maximum 1 from both of them. Else map, that means that if we didn't find it in our map, so what we do is we store it in our map, this new value in our map. And at the end, we just return answer, and this is our code. So let's run the code and see. You can see it is the same answer, and it also has been accepted. So I hope you understood the code. I hope it was a clear explanation. If you did like this video, then give us a thumbs up. Also subscribe to our channel, and I will be back with a new question tomorrow of the Leetcoding challenge. Till then, take care and bye bye.